Hi there. Today we will be discussing the topic of wave energy. By this, we mean the wave energy that is generated by waves in the ocean. To begin, we must consider a very important question. What is wave energy? You may know that many forms of energy, such as sound energy, travel naturally in waves. You may also consider an ordinary cup of water. When left alone on the table, there are no waves. Based on this observation, we can conclude that there is no wave energy in the water in the cup. Since we know that water doesn't naturally travel in waves, we can conclude that the waves we see in the ocean are formed from energy in the water. Now, because waves are energy traveling through the water itself is not actually moving with the waves. What's happening is as the energy moves through the water molecules move upwards. And when the energy leaves that part of the water, those molecules fall back down, so the water itself is not actually moving in the same direction as the energy. You can compare this to two people holding a skipping rope. If one person starts shaking the rope, then waves start moving down the rope, but the rope itself does not actually move. Now that we know that, we must ask ourselves, where does wave energy come from? As you may have noticed, a gust of wind makes a bit of ripples in the water. Windy days tend to have bigger waves. Therefore, the stronger the wind, the larger the waves will be. If we look at it in more detail, we find that wind moving across a body of water makes contact with that water. As the wind moves along the surface of water, friction occurs. This causes a transfer of energy from the wind to the water. As more wind runs along the water, more energy is transferred to the water, causing the waves to get bigger. To fully understand where wave energy comes from, we must understand where the wind energy comes from. The sun heats different parts of the earth at different temperatures using something called solar energy. This is based on many different factors such as latitude, surface elevation, atmosphere, and so on. The warmer air will rise as a result of this, which causes the cooler air to run along the ground as wind to fill in the space that the hot air used to take up. So to sum it all up, the solar energy from the sun transfers wind energy to the air, which transfers wave energy to the water. Now that we have a solid understanding of wave energy, we must consider how it's harnessed or caught to be used to power our households. There have been many different ideas on different structures that could be used to capture wave energy, but only a handful of these designs were efficient enough to be worth using in practice. There are two categories of structures that can be used to capture energy from waves. These are terminators and point absorbers. Again, most wave energy generators can be divided into one of these two categories. Taking a closer look at terminators, these are fixed structures that are positioned perpendicular to the waves. Let's look at an example here. Here's a presentation of an oscillating water column, or an OWC for short. This structure is built on the coast with a chamber that starts above the surface and then dips into the water as shown. As a wave comes into the chamber, the water level rises, causing the air to be compressed out the chamber, which spins the turbine, thus generating the energy. As the water level decreases, air is then displaced back into the chamber once again, causing the turbine to spin. Now let's consider the point absorbers. These structures move with the waves to generate electrical energy. As an example of a point absorber, let's examine the Aquabuoy. The Aquabuoy is anchored in the water and consists of a tank, a generator, and a buoy. When a wave comes under the Aquabuoy, the buoy floats to the crest, the top of the wave, depressurizing the liquid in the tank. As the wave goes by, the buoy sinks to the trough, the bottom of the wave, causing the liquid within the tank to suddenly become pressurized. This constant pressurizing and depressurizing of the tank has the liquid power the generator, which generates the electrical energy. This process can be compared to that of a piston in a car or a pump. As this continues, a cable transfers the energy to a central unit that collects all the electrical energy generated by all the aquaboys, which then sends it back to the coast along the seabed with another cable. By now you should have a pretty good understanding of how wave energy is created and used. Now we need to talk about the key part of any subject in physics, the math behind it. There are many formulas that are associated with wave energy, but we will only focus on two: the formula for energy and power. Let's start with power. The formula for power is P equals pg squared over 64 pi times th squared. It is used to find the power potential of a wave per meter of wave crest. Don't worry, we'll discuss what that means in a second. Looking at the part of the equation, pg squared over 64 pi, where p equals the density of water and g is the acceleration due to gravity, on Earth, we find that all variables have pretty fixed values. This is because the density of water and the acceleration due to gravity on Earth changes very little. As a result, the equation can be simplified to the equation shown in green. T is the time interval between each wave and h is the height of the wave. We end up finding a value for P being measured in kilowatts per meter. This describes the amount of power carried by each horizontal meter of a given wave. Now let's take a look at how we find the amount of energy carried by a wave. The equation for the energy contained in a wave is E equals pgh squared over 8. As we've already established in the power equation, P and G have pretty fixed values, which means that the energy contained by a wave is directly related to the square of its height, meaning the bigger wave, the more energy it has. Now it's time to ask our final two questions. What is it about wave energy that makes it so good? And what about wave energy that makes it not so good? One of the main reasons that people are more interested in wave energy these days is that it is a clean, renewable source of energy. This is just the sort of energy sources that we are looking for to replace energy sources like fossil fuels that are hurting our environment and limited in supply. While it is generally good for the environment, it does pose some potential hazards to the marine environment, including noise pollution, fish death via turbines, changes in water quality and sediment displacement, as well as changes to where professional and recreational fishermen can fish. And of course, clean renewable sources of energy like wave energy don't come very cheap. Building and especially maintenance of water structures are rather pricey. However, these pricey energy sources come with many benefits, such as the ability to anticipate when waves will be a few days in advance, as well as consistency. Very rare is it to have a day that doesn't have enough waves to generate electricity. This makes them particularly useful in times like winter, when other sources of energy like solar and wind aren't as efficient. Furthermore, waves generate massive amounts of energy. If we could reach the technology to exploit the full potential of this energy source, we could power as much as 40% of the Earth's energy needs. Sadly, governments have invested more money into other energy sources like solar, wind, and nuclear, which has made wave energy fall behind in the sophistication of its technology. Who knows what the future holds? Perhaps waves will literally make a brighter future for humankind. Thanks for taking this time to listen to this informative and long presentation.